Welcome everyone to another episode of It Depends podcast. Today, I have a great pleasure of talking to a polite and extremely knowledgeable person. His name is Shirish. Shirish is with SingleStore. And today what we want to talk about is we are going to delve into the world of databases. It used to be operational, analytical, but Shirish will educate us on what is SingleStore, what is the ethos of their database, how is it unique, and what should we expect in terms of new updates and changes in the space of modern data stores. So Shirish, I want to welcome you to this podcast. I am so happy that you took time to come join us today and talk to us.
No, thank you, Sanjeev. It's a pleasure to be here on It Depends podcast. I'm really excited to have this opportunity to talk to you, explore some of the innards of what makes SingleStore the database it is.
That is fantastic. Shirish, it'd be great if you could give us some introduction as to your journey in the data and analytics space and where you've been prior to SingleStore and now your current role.
Yeah. So I joined SingleStore only 3 months ago. In fact, I am a senior vice president of engineering at SingleStore. So I report into the CEO running the engineering efforts, all of engineering efforts at SingleStore. So prior to this, I've spent 15 years at Microsoft. If you count my internship and all that journey, it's more than 15 years. So I've just been at Microsoft most of my professional life, and I have done nothing but databases at Microsoft. I've started my career with SQL Server. I was an engineer in SQL Server, doing various things across 2005 releases of SQL Server 2005 to SQL Server 2012. I've contributed in various pieces, and then I was there in SQL when we were doing the first time moving into the cloud as SQL DB. And then around 2011-12 timeframe, I was one of the founding members of Azure Cosmos DB. This is a non-relational database that Azure decided to go embark on. So that was a fun ride. And I've spent a decade almost building Azure Cosmos DB. I built some of the core pieces like query, inverted index, was responsible for the multi-model API strategy, some of the OSS APIs on top of Cosmos DB. And over the course of time, I've started running the entire engineering efforts for Cosmos DB. Recently, I've taken over responsibilities for Azure, for Citus, which is an acquisition at Microsoft. So this is my not so brief introduction about what I've been doing. Yeah, and I'm happy to delve into it.
It's super interesting. In fact, I want to come back to Citus because Citus is a distributed Postgres.
That's right.
Option, right? Okay, so we'll come back to that once we get into talking about SingleStore. But before we even talk about SingleStore, I have a burning question. I've asked this question to some other vendors. Why should we have yet another relational database? Isn't the space already so crowded? So just want, without even talking about SingleStore technology, it's like, what's a rationale? Why would a customer look at SingleStore?
I agree with you. We don't need yet another relational database the way we think about relational databases in the past. And that's the sort of qualification I would have. My prediction is that Postgres is probably going to be the last sort of like, the vanilla relational databases that we think about. The problem is not about having another relational database. The challenge is when we think about relational databases, they're the classic single node view of the world. All the functionally rich QP, asset guarantees, and all that stuff. The problem is when you try to scale it out, and when you try to really exploit the economies of cloud, when you try to meet the needs of the growing needs of application, you need to take that core piece of relational engine and then sort of scale it out. In the process, you would see a lot of problems when you just kind of go with the vanilla relational databases, and hence there is a need for more databases, and that's why you see all kinds of things that are happening around. There is another macroeconomic factor here, I would say, which is that all these legacy databases are sort of being re-architected, and the application needs are increasing tremendously, and hence we would see more and more of this. So I welcome this change. I think we would have more databases, but not in the way that we used to think about relational databases in the past.
That makes sense. And it's not also just about relation databases, it's also sort of the multi-model, right? So it's sort of the convergence of the relational model with the document model, the key value, the column store, maybe even the graph database, time series.
Yeah.
So
I would think that that's really a great question here, Sanjeev. The point is that when we see the evolution of new databases, you would see a trend that is very clear here. The trend is about convergence. You have way too many relational databases, way too many non-relational databases, many specialized purpose databases. Those are going to converge. It's happening already at a significant pace. Most of the new age databases have relational foundation, but they also support the schema agnosticity, which is in the form of JSON, binary JSON, whatever flavors you have it. But you do want to go to and then there is a next phase of that, which is basically not just support JSON as a type, but make it schema agnostic, right? And I think you would see a lot more databases continue to do that. We are going to do that for sure. The evolution of distributed SQL is effectively a result of that convergence, in my opinion. You're basically bringing the best of the functionally rich QP acid on one side, and the elasticity and the high availability promises. I would say the missing piece is the schema agnosticity. I think that we need to bring it back. But when you sort of if you put that aside for a minute, you see that marriage already happening, right? The vendors, there are multiple vendors in this space. So that is one sort of a major convergence of distributed SQL. There's also equally a good amount of convergence happening on the OLTP, OLAP side with the HTAP side, and with HTAP, the data warehouse and data lakes with lake houses. So the convergence is real. And I think that's happening at an increasingly high pace, which is a welcome news to the industry, I would say.
So SingleStore addresses the HTAP, which is the hybrid transactional analytical processing use cases.
That's correct.
So one database for handling your operational needs and then aggregating that data for high throughput analytical workloads.
That's correct.
So I have a question. So how does this, the HTAP database, sit in this world where we are constantly hearing about cloud data warehouses and lake houses, so data lakes with this ACID layer? So is an HTAP database a third leg of the stool?
I would say if you kind of look at the sort of, obviously you could slice and dice this in various ways. You can catalog these databases in many ways. You've tried it in many Gartner analysis. Allow me to do one more way of doing it.
Yeah, sure.
If you kind of take the big data arrow, right, just the amount of data, big data in defined in, gazillion different ways, but let's take big data arrow. And if you sort of put the spectrum there, on the far left end of the spectrum is the single node databases, right? Postgres, MySQL kind of thing. The far right are basically the data warehouses, the large scale data warehouses, right? The decoupled compute storage and the entire scale out as much as you want, the likes of Snowflake, BigQuery, etc. And then sort of in between, there is a significant amount of space where you need a lot of analytical capabilities combined with the transactional capabilities because of the application needs, right? The killer app for the intermediate space is real-time analytics, right? That's a killer app that didn't exist in its fullest force until probably 4 or 5 years, right? Maybe 10 years, but it kind of came to really a big function in the last couple of years. You have other flavors of those killer apps like graph analytics, etc. But ultimately real-time analytics, which is essentially to say that I want to make operational level latency requests and inserts into my database, but at the same time run very complicated queries. Like, you were talking about tens of group bys and whatnot, right? All kinds of aggregations, etc. So then you have a dilemma. The dilemma is the single node piece, Postgres is not going to do it. MySQL is not going to do it. The scaled out, fully decoupled, like the vanilla versions of the data warehouses are not going to meet the operational needs. You try running a TPCC benchmark on these warehouses, good luck, and it's not going to run. So where do these real-time analytic applications go? Well, they end up with a very complicated architectures, right? And they have their own versions of Lambda and their own versions, there are various ways to slice it, but the problem is that the freshness of data is suspect. So you'd have to do a lot of sort of like compromises. So HTAP existed for a long time, of course. We knew about HTAP for multiple decades now, but the killer app in the form of real-time analytics, I think bubbled up only in the past few years, and that's where there's a significant amount of demand. We think of it as like, I know this analogy of iPhone is a very popular one, but think about it that way, right? Which is, iPhone removes 99% of a need for a professional camera, but it's not going to replace the sort of like the absolutely professional versions. It replaces a need for a different machine for your communications and phone, email, whatnot, right? It removes 99% of it. We believe SingleStore is that general purpose database, and that fits into that line in between. When you talk about the big data spectrum that I talked about, there's a major gap in between, which is where.
Oh wow! This is super enlightening. I didn't see it this way, that there's a whole spectrum and then there's this empty space in the middle. We come across real-time applications. In fact, there are some new data warehouses that claim to be real-time applications, but you're also talking about real-time analytics on operational data and analytical data.
That's correct.
So it's not just a data warehouse function, it's a combination of both.
That's right. So we got to, and building such a database is very hard because you need to invest in a significant amount of analytical capabilities. Typically, column store and the whole sort of like the plethora of query execution, optimization, storage, all that stuff to do the analytical stuff at the pace of an operational sort of like, CRUD, right? That requires some significant amount of engineering and think process. And I'm glad to say that SingleStore has put in that.
Very good. We are going to jump into SingleStore architecture in a few minutes. I do have another question though, which is you were talking about the killer app, which is this real-time analytics on operational analytical data. But I've seen on your website, you talk quite a bit about SingleStore as a database for data-intensive.
That's right.
Application. So what is data-intensive application? How do you define that?
Yeah, no, thank you for bringing that up. And that's sort of really data-intensive is something that we see a lot with our customers, but we struggle to have a common vocabulary to define what they're trying to do and what we are trying to offer, etc. So after a significant number of iterations, we basically have come up with a definition that we think is all-encompassing, and it's a very easy to use kind of a definition. Real-time analytics fits right into the data-intensive applications. It's a little broader than that. I will summarize it. There's an amazing calculator that SingleStore has built. It's available online now. So if you go in and try to sort of like, just answer some of the questions, it'll tell you if your application is a data-intensive application.
Oh, wow.
In a gist.
Yeah.
Sorry.
No, go ahead. I just want to ask you, what are the parameters?
Yeah, the parameters are the following. All right. We start with the volume of the data, how large your data volume is, and you're talking about, a few gigabytes or a few tens of terabytes, hundreds of terabytes and whatnot, right? Data intensive applications typically is on the higher side, of course, right? Ingestion speed, right? It's not just about having data. You can have lots of data, but it may be coming over years or tens of years, etc. That's a very different kind of an application than the one that is sort of like there's a barrage of data coming in a few seconds, minutes, etc. Right? So data intensive applications typically tend to gather that kind of data really fast, right? And then you have the complexity of queries, right? It's not, before we go into the far end of the queries, there is a simple thing, which is I want low latency for my simple operational requirements, right? This is something that most of the data intensive applications require. So low latency is a must, right? The queries are typically very complex. They're not simple queries, not simple key value lookups kind of thing. You could do that in multiple different ways, but queries tend to be, multiple aggregates and sorting group by, and either usually on the analytical side, they tend to be going towards that side, even as you have the simple CRUD operations. So if your application requires those complex queries, then you're on the data intensive side. And then finally, if you have high concurrency, like you want to serve like thousands and like a lot more number of users at any point, typically tend to be a data intensive application. So you don't need to satisfy all of these parameters, but if you satisfy a good number of these parameters, we believe that you're a data intensive application. Real-time analytics, typically it's sort of like a use case of that, and it certainly satisfies those cases. So that's what we mean by data intensive.
I see. So just to summarize, let me know if I got this right. So I'm hearing there are 5 different things. So one is volume, handle very high volume of data. Right. Secondly, streaming ingest or low latency ingest, high velocity data, bring that in. Third thing I heard was data processing ability to join very complex and large number of data elements and speed up that process. And then the fourth and fifth are ability to do low latency and high concurrency analytics.
You got it, Sanjeev.
Okay. So yeah. That is okay. Yes. So let's dig into how SingleStore solves this problem. By the way, why is it called SingleStore? When I started looking at it, we used to call it MemSQL. What happened?
Yeah, no, I think that fits into the equation as to when I explain the architecture, I can touch upon why MemSQL, why SingleStore, etc. But before I go into it, I love the name of the company, because this is one of those rare few times where the company's name and the vision are absolutely aligned. Right? Yes. In many cases where it is hard to understand why is such a legendary company named Apple? What is got to do with the vision? But in this case, we believe it is absolutely aligned. And to kind of answer your question, I'll take a few steps and I'll try to get to why MemSQL, why SingleStore, etc. So to those who don't know, MemSQL was the name of the company before it got rebranded to SingleStore. MemSQL was born in the several years earlier. When we started this company, and I wasn't there, I just joined recently, the founders were betting on the fact that the RAM prices were going to go faster, down faster than the SSD disk prices, right? So in-memory data, building an in-memory database for such a trend would make sense, right? Because the memory is going to go down, price of the memory is going to go down. So we want to keep the memory in the data in and innovate there. And you could do quite a lot when your data is in memory. In fact, the most of the database sort of architectural choices, etc., would be turned upside down when you think about everything being in memory, right? So we've started innovating quite a bit in memory. And that's where MemSQL was born, right? Mm-hmm. So things like we had like raw data structures in memory. If it is in memory, it's fine to have it in rows, trial. One of the intents was to basically build a distributed, highly available, scalable solution, a transactional solution, but in memory. So we had synchronous replication, we had partitions striped across machines, all that stuff was there in memory. And to kind of exploit these benefits, we also built lock-free data structures. Like we had a skip list, we still have it, by the way, skip list indexing. So we have low latency lookups and super optimized. Everything was optimized for memory. We were doing the new generation of query engine where we would compile the query into LLVM. And so we've done all that stuff so that it's a database that was custom built for memory and optimized for memory. And that remains till date. The thing that we started expanding from there was we wanted to, so we built a step one, we got a fastest transactional database, right? So that's really, really cool. Mm-hmm. Now let's add durability to it. Well, okay, so to do a durability, step 2 is to add a transaction lock, right? And it is on SSDs. So it's a fast appends to SSDs. This now allows distributed transactions. You can do redo on this transaction lag, etc. So now we build a great durability. That's step 2. Then what we've decided was, well, okay, then let's cater to the analytics. Step 3 is to build a column store. How do we build a column store? Here, there are multiple choices one could make. One could try to have, like, let's have a proper, solve the problem of extraction and loading, which is basically create another store and a column store, and you move the data, effectively linking the data. That works, but it's not going to be native because you'd have freshness problems, you'd have different query engines, you'd have to optimize differently, you'd have full copy of data, and it's never pretty if you do it that way. Instead, what we've done is basically move the data from row store to column store seamlessly, and the view as to how it happens to any application and anybody on top is seamless. And this is what we call as universal storage. Simply put, we basically keep the fresh data in the row store, and we move transparently into column store depending on some triggers. The triggers are, when we have enough data to pack a segment, this is a column store, right? So we have to have immutable segments. So we move the data into segments at certain triggers, but it is done in a very carefully orchestrated fashion. So we got now column store, and there's a ton of innovations in column store. We could spend some more time on that if we have time. So we got a fast transactional database. We got durability added. We got now column store on memory on the disk. So we weren't happy just with this now. So we've added recently a blob storage, an object storage, right, as the sort of the fourth piece of it, which is tiering the data from memory to SSD to now to AS3 compatible. We do it on all the cloud providers. So you now have a place where you can scale your storage as much as you want, right? And this is just asynchronously replicating the data from the SSD disks to the blob storage, again, based on a few triggers. We evict based on the disk pressure effectively, and we have some caching, and we always innovate on that. So there you have it, right? We started with MemSQL, which is just in memory, fast transactional database, scalable, replicated, all that stuff. We kept all those pieces as is, but we now added durability, column store, and an object store. And then along the way, we've innovated on the query engine, storage, to tackle the piece that I just explained, which is that vacuum in between, and hence the birth of SingleStore, right? That's kind of how the MemSQL to SingleStore happened.
That's a great journey. So step 1 was all in memory transactional. Step 2 was on disk with a transactional log and durability. Step 3 was a column store, also on disk, but instead of doing synchronous replication, you have a trigger mechanism. So you're intelligently deciding where the data goes.
Yeah, so when we move the data from row store to column store, it is just based on a few triggers, like when do we want to pack the segments. It's a classic thing that most of the column stores do, but the view between the row store and column store is extremely tight, in the sense that the query engine understands how to handle the data back and forth. How do we manage the CRUD operations and the analytical operations in a very sensitive fashion between these two.
If I write a SQL query that says select total or select sum of total sales for a certain region by a certain salesperson, then my SQL query in SingleStore query engine will decide what data to pick from the row store because it's fresh, and join it with the data in the column store that has already been copied over.
You absolutely got it. That's exactly what we do. So the query engine and the optimization understands really, hey, this is row store, so we don't have to do different kinds of analysis, different kinds of algorithms. Here is another row store and another piece that we need to get from column store. Oh, by the way, it's compressed. Can we actually work on a compressed data? Yeah, we can. Let's go do that, right? So we sort of like go between both of these in a very seamless fashion. Yes.
So you get the advantage of compression, encoding of data, SIMD, vectorization, all of that.
All of that. Yeah, indeed. Yes. 100%. And this is something that, again, I don't claim that we are the first ones to do it. Clearly, a lot of people have done it, and data warehouses are very aware of this, and they have innovated on it. The thing that matters the most here for us and for most of the data intensive applications is that we get to do both of them in a very cool way. And there's a lot of details here that I'm sort of like brushing through here. For instance, we have an external secondary indexing on the column store, and the way we do that, and that external index itself is a log structured storage. How do we do our level merging? How do we keep the CRUD operations? How do we do our updates efficiently? How do we do sort of single selects easily? There's tons of details which make it both trans analytical applications, right? That's where our value proposition is.
Shirish, one of the things with streaming data is that this data is coming in like super fast, like let's say 5G, IoT, autonomous cars. But what's happening is that the data is sometimes arriving late or it's out of order. I have data coming into my transactional in-memory row store, and it's being compacted. And so based on some triggers, segment fills up, it's written to column store. But now there comes a piece of data which is staggered in late. How do you handle that?
Yeah, so we have something called pipelines. Pipelines is a feature that we've innovated significantly. This helps, and there's quite a lot of detail here, but I'll just summarize this. It effectively is trying to bring a significant amount of data in parallel across all these partitions. We have some inline transformational capabilities for that data. We have some native ability to understand all the common formats, RO, Parquet, JSON, etc., CSV, and all that very efficiently. And we can handle, and we also have innovated to do exactly one semantics. So, which means that all the things that you typically have to do with a message layer, messaging queue layer, etc., is far more simplified on SingleStore here.
So, okay, so this is great. I know we can go deeper and deeper.
Yeah.
I was just going to bring up the whole Kafka cluster, but let's pivot to what's exciting and what's new, because I think that's what we want to talk about on this. And that is the step number 4, which is now the introduction of an object store with asynchronous replication.
Correct. From the disk to, I mean, I would use the word tiering more than replication, because we do have replication to scale out, right? So we have partitions, so we have a shared nothing architecture. So you have partitions, and each partition has multiple replicas. So you can survive, n number of node failures for high availability and whatnot, multi-AZ and all the goodness. This is like tiering, and this is sort of replication, right? So horizontally we go across replicas, etc. So, but what I mean by asynchronous is that moving the data from the disk to blob storage, you're right that it's not synchronous. It happens, asynchronously. That's, maybe we call it asynchronous tiering or something.
Okay, interesting. Yeah, that's an interesting term.
Yeah.
So once we move into an object store, is this idea that we now get separation of compute and store? Is that?
Exactly. That's totally right. And it kind of opens up a lot of things, right? So when you have this kind of a separation, one of the most important things that you could do here is that you could attach extra compute to the same storage, right? So you basically, we call it as a workspaces. In fact, we are going to announce that pretty soon. We view
Workspaces.
Workspaces is the word, is what we're going to call. With that capability, we view the world not as clusters, we view the world as workspaces, where you have a special workspace that does a read and write, and then you have n number of read workspaces, as many as you want, as much on demand as you want. You could just attach and detach, because you could work on a storage that's decoupled from the production workload effectively, right? So that's the beauty of that decoupling. And it's just one of them. There are many other things that you could do once you decouple the storage and compute, right? You could replicate just that storage alone for a storage sort of level disaster recovery. You could attach many other scenarios. You could do a deeply integrated ML on top of that if you want to, and without really impacting the key workload effectively. So you're right, that decoupling helps significantly.
When I hear the word workspaces, It's sort of, and the concept, the way you're explaining it reminds me of Snowflake, for example, with the virtual warehouse. It's a compute,
Sure.
and so it's the same.
You're right. You're right. Yeah, I mean, it's basically what we call as a compute and a compute separation. Like you have, different compute for reasons. So you have the same, and you're ref counting the data effectively, and that's kind of really the same thing.
One of the reasons why Snowflake became such a big force is because of this instant elasticity. How, and I know this is you are not even, you're just announcing it, correct? So this is
Workspace is coming out pretty soon. Yes.
It's coming out. When is it coming out?
So we are gonna announce it in June. So yeah, in a few weeks.
in a few weeks. Okay, perfect. What kind of elasticity do we expect?
Yeah, so effectively, this is sort of like, think of as a major down payment for our elasticity story. We already have a bit of elasticity in the sense that you can start with a fewer nodes and you can add as many nodes as you want, because you just sort of like, you can horizontally scale the database, because naturally you scale it for two reasons. One is for storage and the other is for throughput, right? And throughput is just sort of like a simplification of all the resource usage, right? Compute, memory, IOPS, and all that stuff. And storage is a common thing. We have solved these two in a very methodical fashion. For storage, we've solved it with bottomless, the tiering into the object storage. So if you're happy with your resources, whatever little you have, but you want more storage, we are comfortable by saying that, yeah, you just tier it. You can create a hot, warm, cold kind of a storage tiering if you want. So bring as much as your data as you want. If you're happy with that compute, you don't need to couple the compute needs with the storage needs. Typically what ends up happening is that you have to add more compute, even if you don't need it, just because you need the associated disk with it, right? Don't have that problem in our database. You'd see that in the warehouses, to be very, very honest, but you don't see that kind of stuff in the operational and sort of doing analytics, but in our system you do. So we solve the storage throughput that way, but we still need sort of horizontal scale out for throughput potentially, right? You might need it for like, faster disk access and whatnot, but typically for throughput. And we support that. You can add more nodes on that database, and there are multiple mechanisms to do that. So we scale it that way as well. With Workspaces, it's an advanced flavor of it, because now you can do a scale of the entire workload. You could do a scale out of that entire workload. So we're very excited about that. We're going to continue to innovate on the elasticity piece. The auto scale part that you touched upon is very true with Workspaces, because you can spin up a workspace in a matter of few minutes, and then in fact it's probably less than a minute or something. And then you can remove it when you don't want it. So your workloads that are typically 9 to 5 business days, well, why am I paying for the compute? Don't just spin it off and don't pay for the compute. You only pay for the storage.
Right. And are these clusters or workspaces being spun off using some sort of like a Kubernetes operator? Is that?
So yeah, think of it that way. Basically, all our deployments are cloud native. We have a Kubernetes operator. In fact, we're going to make it publicly accessible. We have that available for anybody who wants to do self-hosting for themselves on-premise or anywhere. We have our own cloud provider operations on all the major clouds. So, we are available across. So Workspaces is really, think of it as like extra compute on your containers effectively. Yes.
I see. So if I have an ETL job that runs at night, I can just bring up
a workspace for that and go for it. Yeah, totally. Yes.
That is great. Okay, excellent. Another thing that I find very interesting, and I feel SingleStore is quite an innovator in the space of Wasm. And Wasm is WebAssembly, is sort of a newer concept for a lot of data management, database people. So please educate us on what is Wasm, what's SingleStore doing?
Totally. Yeah. So, I mean, Wasm is extremely popular for running a lot of pieces that are built not for the web, but we want to run it in the web, right? Because it's really hard to re-implement all that good stuff. So there are very popular applications that have been Wasmed effectively. I think a lot of Amazon's estates like Prime stuff is Wasm, and there are a bunch of things, you go online, you'd find. And that's beautiful innovation, because you can run what's been built for, not for browser, but you sort of take it to the web and run it in browser. When you do that, security is a major problem, right? Security and resource governance, if you so to speak. Wasm provides a safe environment to do that. It's sort of like a sandbox environment where you can run some of these modules. Yeah, there are limitations in terms of what modules can be run in Wasm, because Wasm's runtime has limitations, right? And obviously, because they want to be very careful about what you can do, what you can't do. So even things like pthreads, for example, are not available in Wasm. But Wasm is picking up in its popularity. It's really, really cool idea. Now, when you think about such an idea being natively integrated into the runtime of a query engine, basically it's running next to your data, that sort of opens up a floodgates of innovation, because you have all these modules that you may have written, who knows, you're doing some scoring, some kind of, all kinds of things, NLP, whatnot, right? If you can put that into a Wasm module, and people have done, they've been doing all kinds of things now. And there are different flavors of the languages. It's not even just one language. It's not like JavaScript is the only language of the web. Here you could put like Rust, C, C++, Python, and we're gonna start with a few languages. We're gonna add all of them. So the idea is that you don't have to be just restricted to writing SQL in UDFs and sprocs. You can bring all these modules, run closer to your data in a secure and safe fashion without having to worry about breaches. Yeah, that's another major thing that we are releasing in June. So that's happening as well.
So I come from old school. When we used to write, everything was, in my days at Oracle, PL SQL, we would write a stored procedure. The stored procedure would be saved in the database, and we would run it in the database. So what you're saying is that now I don't have to do that. I can write, if I love Golang or Rust,
right,
I can write my business logic.
That's right.
And where am I executing it?
Yeah, so you basically, again, as I said, there are a few restrictions in terms of what modules can be Wasm compliant, but there's quite a lot of ways to work around for simple business logic, or for some even complicated business logic that can be done, can be moduled into Wasm. You can take Rust, compile it in there, and it runs just like how PL SQL is run in the context of your session. Native to the engine next to your data. You can think of it as exactly the same thing. The boundaries and the sandboxes, etc. There are definitely more security protocols to make sure that an untrusted code, so to speak, is not causing challenges in security, right? Because it could be any module that you downloaded from the internet. So it's effectively should be treated as an untrusted code. PL SQL is a trusted code. You wrote it, you checked in, that has a higher sort of trust boundary, versus in any Wasm module, we allow it. We're fine to do that because the security modeling is very robust. So it's running just like PL SQL, just like T-SQL, any procedural UDFs, same thing.
Yeah, it's probably not a fair question for me to keep comparing with Snowflake and asking all these comparisons, but it's just some of these concepts are new to me. So I just want to understand, in case of Snowflake, they introduced Snowpark, where you can write your code in Python, Java, Scala. Eventually they'll support all these languages, and it gets converted into a native code, SnowSQL, and gets pushed down. So is Wasm doing something similar, except now I can do it in the browser, I can use any language as long as there's a Wasm compiler, and I have the same security benefits? Is Wasm the future of writing your business logic in any language of your choice?
Yeah,
Are they doing the same things, first of all?
I would say they're slightly different in the sense that Wasm is deeply integrated. It's integrated into the runtime of your sort of engine, right? Instead of basically, hey, it's not an external API that you're trying to talk to the engine into. It is natively integrated. Think of it as a UDF store procedure equivalent, except that now you have, modern languages and the power of modern languages. Now, most of the T-SQL, PL-SQLs, they are Turing complete. You could do quite a lot there. It's just that the math functions, the libraries, and all the goodness that's out there in the world, it's not necessarily written in these procedural SQL languages, right? And it's very hard, even though it's a complete language. It's really, really hard to do everything. So yeah, but just like them, they're integrated. That's my point, right? Unlike other options, right? Now we do have great APIs, easy to use APIs to connect with the database from outside in, but this is deep in. It's just like UDF and a store procedure.
I see, got it. Okay, changing tracks. I mentioned earlier on, since you were responsible for the CITES piece, I want to pick your mind on Postgres. Postgres is, you yourself said, is quite an important major database in our space. In fact, I would say in the open space world, Postgres is the gold standard. If I were to say, it's fully open, and so many databases now have Postgres API compatibility. SingleStore has MySQL API compatibility. Why that? Is there going to be a move to Postgres, and what are your thoughts?
Yeah, so you're right that Postgres is certainly fastly evolving and one of the most popular open source projects ever. I think it's probably number 2 right after Linux or something. I think, so just to understand the context here, when SingleStore was born, it was born several years ago. This is a little bit of a historic choice. But the key point though that I want to make here is that we don't have MySQL components that we've picked off the shelf, or we don't have like Postgres components we picked off the shelf or any such thing. Yeah, we do have a few pieces, like, we use Google's spatial S2 library. We actually use a few parser components from certain open source communities, etc. But by and large, this is completely homegrown, right? Including storage, query engine, query optimization, all pieces. What we provide is a wire compatibility to MySQL. We don't actually have behavioral compatibility. We don't have a functional compatibility the way that you think about some other databases. So we are very close to MySQL, MariaDB, because we have wire compat and we try to do all the compatibilities, etc. But we're flexible enough to go change our compatibility. Let's say a behavior of snapshot isolation. Where does it? How there are certain changes in isolation consistency behaviors in every one of these big databases. We're not necessarily married to MySQL the way that you might think that a wire compat database would be. We're flexible. So which means that will allow us to evolve much easily. Unlike, let's say, not to pick on somebody, but let's say Gigabyte, for example, right? Gigabyte uses Postgres query engine as is, like fully 100%, right? And they've innovated on the key value storage piece, but they've used the query engine as is. So they're married to that at the hip. We're not. We can evolve very easily. In fact, we'll certainly consider it. The major focus for us is to go, fulfill the vision of SingleStore and become that general purpose database. As a PG head on top is something that we will certainly consider, and it's not as difficult because we're not married to the to any of those.
So you do your own snapshot isolation and all of that. So basically, if you were to have a Postgres API, it's just a small change, relatively speaking. Nothing is small.
Yeah, I mean, yeah. So I think, to be very honest, when you talk about compatibility, a bug-to-bug compatibility, a feature-to-feature compatibility is near impossible. Nobody can do that unless you basically use the same pieces, right? The key point here is that we will provide so much of the ease of use in the application paradigm so that PG applications can just move over, right? Without having to worry too much about it. And then you have all the beauty of that vacuum that I talked about in that spectrum of big data, right? If you're really, really happy with a single node PG, single node MySQL in just like small data, you're not a data intensive application, you should stay there.
So that's a very interesting point, actually, that I want to bring it up. In fact, I was thinking about it earlier in our discussion. MemSQL was started on this premise that memory is going to get cheaper and cheaper. And so, so why not? But then Flash happened, but Flash turned out to be much cheaper than RAM.
Totally.
However, today we got NVMe.
Rate of deceleration, the price reduction happened faster.
But now with NVMe, memory is again becoming cheaper and abundant.
Yes.
So
we're not moving away from that, and that's the beauty of it. We've tiered all the way from memory to the blob storage, and we believe in that, in sort of like keeping that structure in place. If you think of it, we do log structuring sort of like approach both on disk as well as on blob storage, but we have also this nice vertical tiering that I think is super important as the hardware trends keep evolving. So you're right, it could change, and we need to.
Right. And SingleStore uses NVMe natively?
So we basically have, we don't right now. We basically have our own sort of like a choice of SKUs on every cloud provider.
Yeah. Got it. Okay. Shirish, you've only been in the company 3 months, but how's SingleStore's growth been last 2 years? We've all been locked down more than 2 years now. And something you can share about, which is publicly known, how SingleStore is growing. And I think you got a major funding recently too.
Yeah, so the company has grown massively, right? Ever since we've rebranded from MemSQL to SingleStore, the growth has definitely seen a significant uptick. There's quite a lot of public media details around that. Yes, we had a Series F funding, which is really a massive boost.
Series F.
Yeah, so we had the last one. Yes, correct.
I see.
We've you kind of think of it as like a this evolution has been very gradual, but it certainly took a significant uptick given the switch into the trans-analytic workloads and being a lot more serious about it. It hasn't happened like in just 2 years. The evolution has been gradually picking up, but it sort of like picked up quite fast, right? All those things that happened in the past several years is sort of like, they take one side of the equation, then the last 2 years has seen a different equation altogether, I would say. I think the digital transformation definitely plays well into the, COVID, of course, has seen that digital transformation, the acceleration of it, etc. And the birth of the sort of real-time applications as the killer app. Real-time applications analytics is not necessarily new. It's been there for some time, but I would think that the digital transformation, COVID, the gig economy, as you see, the many applications are popping up who would need the beauty of both operational latency and that complex analytics. So in many ways, I would say that, it's kind of, it feels like a new company and it feels like a new world altogether. Of course, I'm here only for the past 3 months, but it just has seen a total rebirth of that, and acceleration has been amazing, both in terms of our customer acquisitions and all the numbers, of course, growth of the employees as well, and we're growing really well. So all up, I would say that it has picked up quite a bit. HTAP, a killer app as real-time analytics, data-intensive applications is here, and it's growing really fast.
And you have so many new announcements coming, so you're going to be very busy in the month of June. Not that you are, I mean, you're working to launch those things. We talked about quite a few things that are launching: Workspaces, Wasm, the whole idea of object stores. What else did we not talk about that we can expect to see in June?
Yeah, so we are doing quite a lot in terms of how we're evolving our ecosystem, the partner ecosystem. So for instance, we have our connectors with DBT, for example, right? And then there are things around our query engine, which are incredibly important. How we are trying to, again, the expansion of that circle to take the entire vacuum of that spectrum is important. So we've made steps in the direction of improving our analytical capabilities in how a query can take massive amounts of compute. A single query can take we call it as flexible parallelism, for instance, and there's a great blog about it that's going to come out, that's going to be available soon. There are many such innovations, right, that talked about, and then we're working towards this fulfillment of that vision that I talked about, which is the becoming distributed SQL fully, converge the relational, non-relational, OLTP, OLAP, really as fast as we can, with a compelling developer experience, right? And which means that we cannot lose that focus on the analytical capabilities, not to the far right, but to that enough analytical capabilities while becoming the source of truth for a massive number of applications. So, and that's kind of really what we think of as a general purpose database. And so a lot of announcements, a lot of our work is going in that direction effectively.
One of the things that Cosmos DB, which you led, is known for are all these APIs. There's so many different APIs, including MongoDB, Cassandra. Now that you're at SingleStore, what's on your mind?
Yeah, no, this is a great question, Sanjay. So I would say the following, right? When you think about the convergence of relational, non-relational, it's extremely important that a general purpose, sort of like a modern database, need to cover the needs of the schema agnostic database. Most of the data is born as JSON, BSON, JSON, whatever. But most of the data in the modern world, I would say, 80-90% of the data, be it Twitter feeds, weather, traffic, anything, right? It is born as JSON. A database needs to be able to, an operational database in particular, need to be able to provide a mechanism to consume that data in its naked form, right? Without having to curate it and make all the changes, etc. The database that can make it easy to consume it in its naked form will win a host of applications, millions of applications, right? There are obviously going to be the deeper, very, very serious financial commercial applications, which would be comfortable tuning that data into rows and columns, etc. So all I'm saying is that independent of Mongo API or not, we're going to be in the business of giving a compelling experience of JSON, binary JSON, etc. Right? Obviously, Mongo API is a very popular API for handling such data, documents, BSON, JSON, kudos to them. The point is, independent of that, the focus is to make sure that we tap into that massive application market that's out there. Now, when we do that with the differentiation of real-time analytics and all the things that I talked about, that in my mind is a killer solution, and I'm here to build that.
This is phenomenal. First time I've heard somebody say that 80 to 90% of data being produced is in JSON format.
I would think so. I may be wrong, but I would love to be corrected if somebody.
Yeah, no, but this is and you have native support for JSON, CSV, Parquet, Avro.
Absolutely.
I see. That is
meaning we when I say native support, we consume it without having to do anything. We internally do our own encoding, but JSON is a type, is exposed. I know Postgres does it, and there's a lot of new databases are doing it. We need to push that and to make it schema agnostic, not just handle JSON as is, which is a good step, but the data out there needs that schema agnosticity, right? And we're committed to that.
That is great. Shirish, this has been absolutely fabulous. We're reaching end of our time, but I cannot let you go till you tell us something fun and exciting that most of the world does not know about you.
I collect a ton of cricket balls, so I'm a cricket fan.
Cricket ball, wow.
So I go around whenever I see a professional cricket ball. I definitely spend good amount of money in gathering it. So I got tons of kookaburras, the GS, the ones SG, the ones that are made in the subcontinent. So I just love them, and I keep fiddling with them whenever I'm on the calls, etc. So that's sort of.
You have one? Can you show us one?
Yeah, absolutely. I'd love to. Yeah, just give me one.
Oh wow! Yeah, let's see it. Oh wow, a red and a white. So the white one came out like when the night matches started, right?
Yeah, some of those day-night matches, and these are the test matches, for instance, and there are there are tons of them. But now I think there are even pink balls and all kinds of things are
How
coming up. So
how many do you own?
I probably have like 12 or 14 or something like that. Yeah.
I believe there is a massive cricket league forming in the United States.
I read that news just a few days ago. Is this the T20 one that you're referring to?
Somebody was just telling me that there are multiple leagues in the Silicon Valley, in Bay Area, and all other places. It's not just leagues, not teams. There are multiple leagues in each of these.
Oh, wow. Regions. I did read a news yesterday, or I don't know when, but I think what it said was that Satya, Microsoft CEO Satya, and Shantanu, Adobe, I think they and some other people are sponsoring T20 in the US, wow. which is a great news.
A World Cup, cricket World Cup. By the way, before we leave, this is a trivia question that I've asked people maybe over 15, 20 years, and very few people get it right. Where in the world did the first international cricket match take place? And the answer is United States.
Oh, is it like in the Caribbean or?
No, it was in I think in Florida. This was, you're talking about like 100 years or a long time ago, before cricket became mainstream.
That's interesting. Is it because of the lack of stadiums and Florida had one? They converted a baseball stadium. Is that?
I think maybe the British influence was still lingering in the US, and so.
I would have said England. I mean, Lords is sort of like the home country. So, but this is the US. I'm gonna go dig into it.
Yeah, please do. Maybe my memory doesn't serve me right, but but this would be great. It sounds like we need another episode just to talk about cricket.
To come back to you
now. This has been fantastic. Thank you so much. I learned so much on this episode, and I'm sure there is so much more we can dig into with Wasm and all the query enhancements and how your query engine picks out. But thank you so much for your time.
Yeah, we look forward to the summer launch, and would love to share more details at It Depends podcast. Thank you so much for having me here, Sanjeev.
Thank you so much. Thanks everyone. Thanks for joining.